Good morning. Welcome to the webinar series on managing drought in the Southern Plains. I'm Margaret Boone with the Southern Climate Impacts Planning Program. I will be the moderator for today's webinar. Rachel Riley, SCIP Associate Program Manager, will be managing the webinar. This week's presentation topic will focus on what has changed over the past 6 to 8 months. Presenters include Brian Fuchs from the National Drought Mitigation Center, Bob Rose from the Lower Colorado River Authority, John Nielsen-Gammon, Texas State Climatologist, and Pat Guinan, Missouri State Climatologist. Presentations will focus on how things have changed in water resources, specifically how much recovery there has been and how this affects us, as well as what the current ENSO values indicate for the coming year. We'll also discuss the re-emerging drought in Missouri and look at whether this is a flash drought or something more permanent. As always, the webinar will feature an update and outlook on the region's drought conditions from Brian Fuchs at the National Drought Monitor. I would like to recognize the support of those who made this webinar possible. Chad McNutt with the National Integrated Drought Information, Hayes with the National Drought Mitigation Center, Dave Brown with NOAA's Regional Climate Services, and the SCIP and CLIMAS NOAA RESA teams. We also greatly appreciate those of you who join us in this webinar series and recognize the valuable time that you commit to participating. Please notice the poll that is up on your screen. At each webinar, we provide an opportunity for you to tell us what topics are of most interest to you. Information to line up topics and presenters. You can also let us know through the chat box or through emailing or calling SCIP. Our next webinar will be on June 28th, which will be a shortened briefing version. That will be posted on SCIP's YouTube channel. Our next full webinar with focus topic will be on July 12th with a You may ask questions or make comments at any time through typing in your chat box. We will now begin with an update of current conditions from Brian Fuchs.
All right, good morning, everyone, and thank you for the introduction, Margaret. Again, I'm Brian Fuchs with the National Drought Mitigation Center at the School of Natural Resources at the University of Nebraska in Lincoln, and also one of the U.S. Drought Monitor authors. And I'll be giving the update on current conditions and also just a little look at where we've been in the last year or so. So first slide, please. And so to start off with, I wanted to show where we were at this point in time last year. And you can see that the U.S. as a whole, most of the drought that we were seeing, in fact, all the drought that we were seeing outside of the Hawaiian Islands was basically taking place from Kansas, Oklahoma, New Mexico, Arizona, Texas, and then along the southern Gulf Coast and into the southeast. That most of the northern half of the U.S. was basically in fine shape and in good conditions. And again, we were looking at flooding conditions along the Missouri River corridor. So again, this is where we were in 2011. Next slide. Looking at today's release of the Drought Monitor. And a couple contrasts to really point out. We don't see the large area of intense, extreme to exceptional drought through the southern plains that we did last year at this time, but there's a lot more color on the map. We can see a lot of developing drought issues, not only in the Midwest and Central Plains, but also in the Western U.S. that we did not see last year at this time at all. We have seen some recovery in the last year, looking at conditions in Oklahoma, Texas, and along parts of the Gulf Coast compared to last year. There has been quite a bit of improvement, but we do see some lingering drought that is taking place in West Texas and into eastern New Mexico, and then some developing drought in the Central Rockies, as well as lingering drought in the Southeast. And we're going to speak about it a little bit more, but there's that area from Arkansas through southern Missouri and into the eastern Corn Belt that has really popped up in the last several weeks. And we're seeing quite a bit of dryness for a time of the year that's one of the climatologically wettest of the year. So along with some of the heat that we've experienced, there are problems developing And some of that goes on to conditions that we're seeing last fall and into the winter with the lack of recharge into the soil moisture profile, especially for ag producers in those regions. Next slide. Again, this is a zoom in of the region and where we're at as of this week. Looking again, most of eastern portions of Oklahoma and into East Texas in that are really looking fairly decent compared to where we were. We're still looking at these areas. I think the date is wrong on this map. Go to the next slide for me, please. Oh, I'm sorry. Go back one slide. I know what I wanted to show was this is where we were at the last call, what we were looking at through the region, and seeing just exactly what we've improved upon over this time frame. And during this last 6 weeks or so, the D4 conditions have really improved. If we go to the next map or the next slide, we can see that outside of a very small pocket of D4 in Texas, almost all the D4 has been eliminated. And even the amount of D3 in the region has really declined. What we're looking at, though, if you look at the D1 through D4 numbers, we're at about 66%. And compared to last week, that was at 64%. We've seen that little bit of an uptick, and a lot of that has come in the areas of Arkansas, into southern Missouri, portions of Kansas, and even into New Mexico, where those areas that have not picked up the rains over the last several months, we're seeing declining conditions as of right now and moving forward. Next slide. Pulled up some of the ACES products from the regional climate centers and the 30-day departure from normal product in the upper right. We're looking at areas anywhere from being up to 3 inches to maybe even approaching 6 inches below normal in portions of Texas, East Texas, eastern Oklahoma, southeast Kansas, and much of western Arkansas and into Louisiana. And the 60-day departure from normal, you can really see that 3 to 6 inch deficit that was developing from Arkansas into Missouri, into Kentucky, portions of northern Texas, eastern Oklahoma. Again, for a very wet time of the year, we have seen rainfall, but through the last 2 months, there has been a deficit developing. Next slide. Year to date, departure of normal, you can see the improvements that were made from the rains in Texas and portions of Louisiana for year to date. And even what really stands out is along that Mississippi corridor from Arkansas into Tennessee, southern Missouri, into Kentucky and Illinois, that those departures are anywhere from 4 to 8 inches, even approaching 12 inches in some places for just the calendar year. And then the 12-month departure from normal, you take out that wet spell that we had seen where some of the recovery was made in the region, but you can still see some pockets of dryness along the Texas Gulf Coast, along the Texas-Oklahoma border and into southern Arkansas, where some of those departures over the last 12 months are 16 to 20 inches as far as that deficit goes. So even with some of the rain and improvements that we've seen, to me, the area is still vulnerable, and there are some lingering deficits that are probably impacting hydrological conditions more than anything still in those regions, and I'll let others speak to that. Next slide. Just looking at this short-term or flash drought developing, and the 30-day SPI, I highlighted one area, but it's not centralized just to that area. But you can really see that these SPI values on the 30-day and then on the 60-day down below, if you correlate these to conditions that we show on the U.S. Drought Monitor just with these SPI values, these are values that are going to be in the D3 to D4 range. And you can see that it goes all the way, especially in the last 30 days, all the way from Ohio through much of the Midwest, almost all of the state of Missouri, a great portion of Arkansas into northern Louisiana, and southern Nebraska and northern Kansas as well. You can see that it's been a very dry pattern through this central part of the country, and even at the 60-day time frame, some of those pockets really are standing out as far as just how dry they are. Next slide. And that's going to give you an idea of just the dryness in the region and in the U.S. as a whole. And then moving forward with the 5-day outlook, temperatures look to stay elevated through much of the Midwest and into the central and southern plains, with departures of anywhere from 3 to 6 degrees above normal in West Texas, New Mexico, and Colorado, to even 9 degrees above normal up in the Great Lakes region. And the precipitation outlook, this is the QPF outlook from for the next 5 days, and it's jumped around. I've been following it for most of this week, and the areas of the greatest precipitation has really jumped around, and we're seeing that there are chances all the way from up in Wisconsin and Minnesota, which they're currently getting some fairly substantial rains right now, all the way down through Iowa and into portions of southeast Nebraska, and maybe even into eastern Kansas and northwestern Missouri, with this greatest chance of precipitation. Then we also see some decent precipitation amounts pushing in through the Gulf Coast region, as well as the Gulf Coast of Texas and into East Texas and southern Louisiana. Again, we'll see how this plays out. Climatologically, a lot of these areas should be expecting right around an inch of rain to even an inch and a half of rain, depending on where you're at for this time of year. So seeing some of these amounts, that does show that maybe some of that of the deficits over the last 30 to 60 days could be improved upon a little bit. Next slide. The 8 to 14 day outlook on the upper right panel, we're looking at the temperatures, and the best chances for above normal temperatures look to be in that Four Corners region into Wyoming and West Texas, also along the southeast and into the mid-Atlantic states and up into New England. For precipitation, it looks like over the next 8 to 14 days, normal or near normal chances of precipitation through much of the central U.S., and the probability of below normal precipitation is increased over eastern New Mexico, West Texas during that time frame. Next slide. This is the seasonal outlook here, looking in for June and then into the summer. We see that temperature profile maintains itself over much of the country during this time frame, where the best chances of above normal temperatures in June is looking right through Kansas, western Missouri, northern Texas, and eastern New Mexico during that time, with precipitation chances looking best over the northern part of the country. And for the summer months, we see this warm signal continuing to show itself for June, July, and August, and equal chances to below normal in portions of the Pacific Northwest as far as precipitation. So what does that tell us? That moving forward, we're not going to see any reprieve to the heat that we've experienced for this entire calendar year. One of the warmest years on record up to this point. We're going to maintain that. And right now, as far as precipitation chances go, equal chances through much of the region through the summer months. And so again, what's expected with that is a normal weather pattern. Okay, and next slide. And here's the seasonal drought outlook that was released last week from the Climate Prediction Center. What it's looking at is areas where we can see some developing or improvements to the current status of the U.S. Drought Monitor. And what we're seeing through the southern plains is persistence and development for much of the area, especially looking at the areas of southern Missouri, Arkansas, southern Texas, and along the Gulf Coast. There are persisting conditions. Developing drought in portions of Colorado and Nebraska and northern Missouri into Illinois. And what they're showing is this improvement, or even some improvement to improvement, which on this product is basically a one category improvement on the U.S. Drought Monitor is how they're looking at this. And they're showing a fairly strong signal for some improvement through portions of the Southwest, Arizona, New Mexico, and into West Texas. So we'll see how this verifies and see any changes that come out with the next release, which should be next week. Next slide. Again, here is the U.S. Drought Monitor from June of last year, just to kind of show where we were at and the improvements we've made in portions of the region, but not all the region, and how drought has become problematic, especially on the short term, the short-term flash drought development over much of the Midwest and along the Mississippi Valley during this time. I think that is my last slide. Yes, my contact information, if you'd like to reach me, is below, and I'll pass the torch on to the next speaker.
Thank you so much, Brian. We'll now move to Bob Rose with the Lower Colorado.
Thank you very much. Good morning, everyone. We've seen limited improvement across our basin over the winter period, but drought conditions still are affecting our region quite a bit, especially from a water supply standpoint. So I thought I'd bring everyone up to date as where things are today compared to when we talked last fall. On the next slide, just a little bit of review for you about the Lower Colorado River. Again, we're talking about the Colorado River in Texas. And our portion of the river, it covers the region across the hill country, below Lake Ivy, and then downstream through the city of Austin, and then along the river all the way down to the Gulf of Mexico. But our watershed, where we actually receive rain that turns into runoff, is generally all across the hill country to the west and to the north of Austin. On the next slide, just wanted to show you that we have two water storage reservoirs. One is Lake Buchanan on the northern end of the river, and then Lake Travis just to the north of Austin. These, again, are our two water supply reservoirs. So when I talk about combined storage here in a minute, these are the two reservoirs I'm going to be talking about. On the next slide, just a quick review that in the beginning of this drought in October of 2011, and looking through September of October of 2010 through September of 2011, rainfall was well below normal across all of south central Texas. In most areas, rainfall was more than 20 inches below normal. It was the driest 12-month period ever recorded for this region. And as a result, we saw very little runoff into our lake system. On the next slide, just wanted to show you where we measure, where there are 4 points where we measure inflows. These are along the major tributaries into those two lakes. And you can see those on the screen. So as we go to the next slide, this is a look at calendar year 2011 on the next slide of looking at the inflows into the lake system. And it will show you that the inflows were well below normal throughout the year. In fact, it was the lowest calendar year ever for inflows. If we could get that next slide, by the way.
Bob, hold on. Sorry about that. It
okay,
it disappeared on me. And
okay.
1 second. Let me see if it got hidden behind Windows. All right. Sorry about that.
No problem. This chart may be a little confusing at first, but if you look at the green bar, this is the actual measurement of inflows into our two lakes system by month, and you can see that the green bar was extremely low throughout the year. The blue bar up there is what the long-term average is, and also listed up there is 2009, another very dry year that we just came off of only about 2 years prior. As we got to the summer months in June, many of the tributaries started to dry up, and you can see that by July, we only got 720 acre feet. August was 367, September was 650. You see below where I wrote 3rd, 4th, and 5th. These are the 3rd, 4th, and 5th lowest months of monthly inflows into the lakes ever recorded. As we got to October and some rains did occur where the inflows did pick up, but you could see they were still well below normal. November was well below normal in December as well. For the calendar year, it ended up we only got 10% of what the historical annual average ever it was. And for 2011, we ended up with a little over 127,000 acre feet. Normal year is about 1.25 million acre feet. As you can see, it was very, very low. So moving ahead, we did see scattered rains over the fall period and then through the winter months. And we did have a bit of rain in March. The rain kind of decreased in April. We had a little bit of rain in early May as well. This is from the National Weather Service looking at the rainfall departure from normal just since January 1 through June 12th. And you can see that for much of the area, we've had either normal to a little bit above normal rain, especially in the hill country. We've had several spots. that have been either 2 to 4, 4 to 6 inches above normal over that period. But again, nothing extremely wet. A lot of the really heavy rains have missed our basin, either off to the north or off to the west. But also, because the soil was so dry going into this year, much of this rain sank into the soil instead of running off. On the next slide, you will see this is the inflows we have seen so far this year. And on this particular slide, 2012 is the gray bar. The blue bar, again, is what the average is. And 2011 is noted in the green. So you noticed for January, we're still well below normal. We were a little bit ahead of January of last year. For February, we were still below normal, but well ahead of last year. And in March, we actually, for the first time in a year and a half, we actually exceeded what we typically see in the month of March. We actually exceeded the monthly average inflows. But again, nothing spectacular. As we got into April, as I mentioned, the rain sort of curtailed a bit, and our inflows dropped way back. And for May, although it's not listed up there, they were way below normal because the second half of May, we actually saw almost no rain across the area. So not a spectacular start to the year, but it is better than where we were in 2011. Moving along to the next slide. I wanted to show you where our two current reservoirs are. Lake Buchanan, the most northern reservoir, is about 52% full. Lake Travis on the southern end is about 49% full with 560,000 acre feet. As a system, we have a little over 1 million acre feet. We're about 51% full. So we really haven't seen a huge amount of recovery. At our lowest point last fall, our system had gotten down to 37% of capacity, the third lowest point ever measured since these two reservoirs have been built. On the next slide, I wanted to show you a couple of things on here. One is this is looking at where we have been on the left-hand side of this graph up to the sort of yellow vertical line, and then there's a forecast off toward the right. So this takes us back to December, and again, our lake system was about 37% full. And then you can see how the trace starts to rise a little bit as we get toward February and March. It took that long to finally saturate the soil and start getting some runoff. And you can see that each one of those particular heavy rain events, you can see that the combined storage did go up a bit. And then we kind of leveled off between April going into May and then into June. Right now, again, our system is about 51% full. So we have, we're better than we were late last fall, but we still have a long way to go to get out of this drought. On the right, to the right of that yellow vertical bar is a forecast of where we think our system will go based on different scenarios. Those two red lines down at the bottom is if the weather stays unusually dry, we expect that our lake system will be back where it was last fall, down around 35 to 37% full later this year. If we get into a wetter regime later this fall and going into the winter, the lake system should start filling up. But, again, a lot of uncertainty in that. Again, we operate our lake system, though, with a water management plan, and there's various triggers on the right. I don't want to spend a lot of time talking about that. But one of the things that we faced going into this year was the fact that our lakes were very low, and we do release a lot of water for agricultural or what we call interruptible water. And according to our water management plan, we would have been forced to release at least a limited amount of water to our agricultural interests downstream, despite having such low lake levels. But LCRA went to the Texas Commission on Environmental Quality and actually petitioned them to modify the water management plan this winter, that if we did not have 850,000 acre feet by March the 15th, we would not have water for agriculture. Well, as it turns out, we did not have quite 850,000 acre feet. Our point was that releasing that limited amount of water would only have gotten a crop started, and then we wouldn't have enough water to follow up to get those crops maturing. So the water, in effect, would not have really done that much good, and it would have caused our lakes to go even lower. The TCEQ agreed with us, and because the lakes did not reach 850,000 acre feet by March 15th, we are not releasing water for agriculture this year. This is the first time ever in LCRA's history that we are curtailing and cut off almost all of our agricultural releases. In fact, on the next slide, you'll see this is the impact of the low lake levels and this relief order we got through the TCEQ. is precluded us from releasing water for rice irrigation this year. There is one small area that has had very historical rights to the river, and we are delivering a small amount of water to them, but that is just a fraction of what is normally delivered to our entire rice growing area. It's interesting to note that the rice growing area downstream of Austin, down along the coast, represents about 5 to 10% of all of the rice grown nationally, and about 55 to 60% of all of the rice that is grown in Texas is, again, along the lower Colorado River. Like I mentioned earlier, this is the first time ever that we have curtailed agriculture downstream of Austin. And along with that, though, also very strict water restrictions remain in place for the city of Austin and any of the other small cities that do draw water out of either Lake Travis or Lake Buchanan or the system for their drinking water. So looking ahead to the future, we're still seeing a fairly bleak picture for the rest of this year until rains do return, because our reservoirs are only half full. We don't really have a lot of water to spare for agriculture at this point. So we're all waiting on El Nino to see if we will see some sort of recovery later this year. But there's a lot of concern that if rains don't return later this year, that we'll be facing the same situation next year, that we won't have water for agriculture. So an interesting time for LCRA, for the residents of Central Texas, and certainly the agricultural industry below Austin. So with that, that's the end of my presentation. That's my contact information. If you have any questions, feel free to contact me, and I'll turn it back over to Margaret.
Thank you so much, Bob. We'll now move on to John Nielsen-Gammon, who's going to give us an update.
Thank you. Yeah, I'm going to look at what's been going on where most of the planet's water is located and how it's been affecting our weather and likely to affect in the future. Next slide, please. So this is a plot of ocean temperatures in the tropical Pacific. From left to right, you're running from basically New Guinea to Ecuador and Peru. And time is going downward, so that the conditions a year ago are on the top of the diagram and current conditions are on the bottom. And what's being shown in color is the departure from normal of the tropical sea surface temperatures. So we pick it up at the top at the beginning of last summer when we were just coming out of a La Nina event. La Nina is defined as temperatures being at least a half a degree Celsius below normal, averaged over a several month period, roughly in the area between about 150 west to 180 west. And what you see is that we were essentially in neutral conditions a year ago, but La Nina developed, conditions got cold enough to pass that threshold around August, and we were deep in a La Nina by the winter time. It wasn't as extreme as last year's La Nina, but it persisted through the winter time. On the other hand, we had normally La Nina conditions mean dry conditions across the southern United States on average, but each year is different because of particular wave patterns in the jet stream and what's happening over the Atlantic Ocean and so forth. And this particular time around, the South Central United States was relatively lucky compared to places farther west and farther east. Southwest and southeast were relatively dry with this La Nina, whereas Texas, for example, averaged above normal rainfall for the wintertime, which only happens about 1 La Nina out of 5. Around February, we started seeing warmer ocean temperatures off the coast of Peru, and at the same time, temperatures started becoming less cool farther out near the dateline. And by April, La Nina was ending, and we presently see along the tropics, along the bottom of the graph, mostly near normal to some above normal temperatures. So presently conditions are in an ENSO neutral state, but the Climate Prediction Center has issued an ENSO watch, which means that chance that El Nino conditions are likely to develop within the next 6 months. Next slide, please. This is this is last year's sea surface temperature pattern globally, representative departures from normal. It's not just the tropical Pacific that affects the weather. There are also influences from the Atlantic Ocean. Temperatures in the North Pacific probably affect the jet stream pattern as well. And what we were looking at going into the summertime last year was unusually cold temperatures still persisting north of the equator in the tropical Pacific. And meanwhile, in the tropical Atlantic, we had strongly above normal temperatures. Atlantic Ocean temperatures and south central rainfall tend to be anti-correlated, which means that you have warm temperatures in the tropical Atlantic, the Caribbean, Gulf of Mexico. You tend to have below normal rainfall during the summertime. Mainly it's a matter of you're only going to get so much thunderstorm activity in the region, and if the most unstable air is over the water because the water's warm, then that's where the thunderstorms will tend to take place. So this was the situation last year. Next slide shows the current year's pattern. And why don't you flip back and forth between these two slides a couple times. You notice that in the North Pacific, things really aren't much different now than they were last year. Meanwhile, though, right in the tropics, the tropical temperatures along the equator are warmer than they were, and southern hemisphere is completely different. So we almost have half of the lingering ENSO pattern with the persistent cold temperatures in the subtropics. It will be interesting to see how much of an effect that has. Basically, we've got a pattern that's consistent with the Pacific decadal oscillation being on the in the phase that inhibits rainfall in Texas, but meanwhile, in the shorter term, El Nino is near normal. Over in the Atlantic, we don't have the patch of unusually warm temperatures in the tropical Atlantic and the Eastern Caribbean that we had last year. So things look a little bit more favorable for rainfall over land based on that indicator. That's also the reason that the hurricane forecast is near normal rather than above normal like it's been for most of the past 15 years. Combination of La Nina going away, the threat of El Nino developing, and near normal tropical Atlantic sea surface temperatures. Next slide, please. Brian has already showed you the outlook for the summertime, the rainfall, with basically nothing strongly warm or cold in the tropical Pacific or the Atlantic. Means there's really no signal to hang your hat on for rainfall across southern United States. So equal chances of above, near normal, and below normal being forecasted. Next slide, please. Warmer temperatures partly perhaps as a persistent signal lingering from La Nina. It takes the atmosphere a few months to respond to the change in the sea surface temperatures. This is, as mentioned earlier, is not a good sign for drought because it means increased evaporation, increased water stress by plants, even if the rainfall ends up being near normal. For most of the south central region, with the exception of New Mexico and far west Texas, July is a dry month, both in terms of the amount of rainfall and especially in terms of the difference between rainfall and potential evaporation. Next slide. Looking forward to the wintertime, the temperature pattern is the complete opposite in the forecast. Instead of the southern United States being above normal, northern United States is forecast as being above normal. This is sort of a combination of two signals. We have an increased chance of warm temperatures in the northern U.S. because of the possibility of El Nino developing. El Nino would also ordinarily lead to below normal temperatures in the southern United States, But then when you factor in the fact that temperatures have been rising over the past several decades in the southern United States, that tends to cancel out the effect of El Nino in terms of temperatures, at least in the eyes of the Climate Prediction Center. And next slide. This is information-loaded slide with the precipitation probability. Actually, the ECs you see here are forecasts of an early Christmas. But not a whole lot to hang one's hat on at this point. Still several months into the future. Still not certain that an El Nino is going to develop. As we move on through the summer and as the tropical Pacific SSTs evolve, we'll start seeing some color showing up on this map. I think that's the last slide I have. Is there anything else there? Oh, okay, summary. So we still got the Pacific and Atlantic long-term signals unfavorable for rainfall in the southwest United States. So we're still in a period of drought susceptibility, and current drought monitor map is consistent with that. In the short term, there's a small amount of hope for the summer because we have, according to the forecast, a 33% chance of having significantly more rainfall than normal. But as going into the winter, there's more hope, mainly associated with the possibility of an El Nino developing this time around. Still not showing up as concrete changes in the precipitation outlook, but at least it's something to hope for. That concludes my summary.
Thank you so much, John. Pat Guinan will.
Thank you, Margaret. First slide, please. Next slide. We have a situation in Missouri that's pretty similar to a situation that evolved in southwestern Missouri last July, where we had a lack of precipitation, but we also had some unusually high temperatures we hadn't seen in more than 30 years that literally put a drought situation in fast forward. The current situation is something that's occurred over about the past 5.5 weeks, generally after the first week of May up to now. You can see the precipitation deficit across the country, and Missouri is pretty much in a bullseye in regard to the deficits we've racked up over the past 5.5 weeks of anywhere to 4 to 6 inches below normal. What's very concerning about that situation is typically this is our wettest time of year. And literally, there are some locations in the state, especially northern and central sections, a little bit of southeast Missouri, that has seen less than an inch, even less than a half inch of rain over about the past 5.5 weeks or so. And we still have summer to contend with. And so, and that's also spread across portions of Kansas, southeast Nebraska, Iowa, and is impacting a good portion of the Corn Belt. Next slide, please. In addition to the lack of precipitation we've seen in May and the first half of June, the temperatures have been unusually warm during the month of May. In fact, I believe it was the second warmest May on record for the United States. Here in Missouri, we averaged about 5 degrees above normal, and that ranked in the top 5, at least that's what the preliminary data is indicating, the top 5 warmest Mays of record. Next slide, please. In combination with the lack of precipitation and the above normal temperatures that started in May, this is a map showing the vapor pressure deficit. And I've used this variable, what I call the VPD. It's basically the difference between the amount of moisture in the air and then how much moisture the air can hold when it is saturated. And it's been related in regard with the field of plant science on the amount of moisture loss that you get from a plant, or transpiration is what we call it. And generally, the higher the VPD relates to more moisture loss from a plant. And so the vapor pressure deficit can enhance or inhibit the crop's ability to transpire. And the green dots are indicative of over an 18-year period, using data from automated weather stations here in mid-Missouri. The green dots indicate the daily average vapor pressure deficit for the month of May, from May 1st through the 31st. And then the orange dots are the vapor pressure deficits for 2012. And you can see they've been, for the most part, very high, which translates to high moisture loss from plants. And that has been a contributor towards this flash drought scenario. Next slide, please. In addition, another driver of moisture loss is solar radiation. And this, again, is using automated weather station data from pyronometers here in mid-Missouri. The blue dots indicate the 18-year average, daily average of solar radiation output, that is direct plus scattered radiation. And then the pink dots are what happened in 2012. And you can see the radiation was much higher in 2012 compared to the normal for the month of May. And solar radiation is the biggest driver in regard to moisture loss that you get from the soil profile as well as from vegetation. And it's these ingredients that we've seen this year, even just for the very short time period in May, with lack of precip, high temperatures, high vapor pressure deficits, and high solar radiation output, that we've seen some very high potential evapotranspiration. And the next slide, please. And this does show the daily May evapotranspiration rates here in mid-Missouri, and it's fairly uniform across the state for this and from the previous variables I had mentioned, with the exception of precipitation. But you can see the high ET rates that have been occurring during the month of May, many days above 0.2 of an inch. The total was nearly 6 inches, which is more representative of a summertime evapotranspiration rate. So it's these ingredients that have really put this drought on fast forward and is raising a lot of concern on already crop stress impacts in that regard. Next slide, please. Of course, there are other variables that can impact moisture loss or evapotranspiration, that being wind speed. And here in Missouri, I think we're more vulnerable to a flash drought situation compared to, say, other states like Iowa or Illinois. And what plays into the equation are soil properties. Of course, the soil moisture condition and the type of soil. Here in Missouri, a significant amount of the soil has a high clay content, and in Southwest Missouri especially, we have a very shallow topsoil. And so there's more of a vulnerability component that goes with it versus the soil profiles we see in Illinois and Iowa that have much more silt and are a little bit more better in regard to retaining that soil moisture condition. So it doesn't take long to see these flash drought conditions which really ramp up here in Missouri. And of course, the time of year, we've reached a stage here in May, a very vulnerable stage where crops are still young, root systems are developing in corn. And these are pictures I took just last week here in mid-Missouri showing the crop stress already in corn, which is not really growing. We have poor root development. We're starting to see a little bit of firing and curling of the leaves. And then on the right side, you can see the soybean emergence has been uneven because literally there is no moisture for some of the soybean to tap into to germinate and emerge. So I think the next slide, please, or the last slide. What we're doing here in Missouri to try to show what's happening and what can happen so quickly in regard to the stress and the impacts that we're seeing, we were sort of caught off guard last year with the high temperatures in Southwest Missouri and how fast things went downhill. Literally, the corn crop was a loss towards the end of July, and yet some of the magnitude and the severity of the drought condition across Southwest Missouri wasn't really matching up with what the impacts were. And in my opinion, I think we're seeing that this year too. In fact, I gather to say we're maybe running a couple weeks behind normal in capturing the impacts that have already been going on in Missouri. And so what we're trying to do is encourage participation in the Drought Impact Reporter. And last year we submitted a news release to get the word out on how people can be involved in the drought decision process. And it has helped out a little bit, but we just need to keep hammering home how people can participate, submit impacts, and hopefully get a better feel on the drought and the magnitude of drought that's impacting the region. I've always said, who knows the drought better than a person who's actually living in the affected areas. So hopefully we'll see more participation here in Missouri, because I already think we're a little bit behind in regard to accurately representing some portions of the state in the right severity level of drought, at least according to the Drought Monitor. Margaret, that's pretty much what I have for today. Thanks for the opportunity.
Thank you, Pat. And I also want to say thank you to Brian, Bob, and John. I think we also have Mary Knapp online to talk about.
Hello, can you hear me?
Yes, we can hear you.
Okay, basically, in Kansas, we're looking at similar conditions that Pat mentioned. Ours are more in the central and western part of the state, in particularly north central Kansas, which did not see the moisture that the rest of the state saw during our winter months. We're not seeing quite so much stress in our southeastern portion of the state because they did get very plentiful rains in April and the first part of May, so they've got a little bit longer lead time, if you will. But again, things are going downhill very, very quickly. What's notable in our western areas is that a lot of the conservation reserve and grasslands simply did not green up this spring. And it's a question of how much they suffered from the drought last year and you know, what kind of mortality they're actually seeing in their crops. There are a few locations where, believe it or not, people are planning on double cropping sorghum or beans after wheat because our wheat harvest was so early. We're over halfway complete with the wheat harvest, which is a good 3 weeks ahead of what they would normally expect. So again, we're monitoring very carefully because the rains have been disappointing. I saw in the earlier outlook of the 5-day precip outlook, and you're looking at between 1.5 to maybe as much as 3 inches for areas of Kansas. But keep in mind, 1.5 would not be normal rainfall for a weekly period in parts of central and eastern Kansas. So it may be enough to allow row crops to hang on. It's not going to address the underlying hydrological deficit. That's basically what I've got.
Thank you, Mary. We will now open it up to any questions or comments that anybody has. And we'll also leave a list of resources on the screen. As a reminder, these presentation materials will be posted to the Drought portal. The Southern will be prepared and posted by early next week. Webinar recording will be posted to the Skip YouTube. We'll also have a link to it on our Facebook. Our next webinar will be on June 28th. Full webinar will be on July 12th. We just encourage you to continue to spread the word to make sure all of those dealing with aspects of this drought are part of this larger community and can access support they need. We encourage you to pass along the PDF summaries, our webinar announcements, or any other information linked on these various websites. Thank you for your time, and thank you to our speakers, and we look forward to continuing this conversation with you in the future.
Thank you.